same point travels south 60 miles per hour. How fast is the distance between increasing at 3? So I got a train station, I guess. I got one train that's going 45 miles per hour east. So this is where I started at. This is my train. And then I got one that's going south. And that's where this one's at. And the question is, how fast is the distance between them increasing at exactly 3 o'clock? So, what's my equation again?
X squared plus y squared equals z squared.
So I got another simple little Pythagorean thing. So we'll say x, we'll say y, we'll say z. So my derivative will be the same. We're taking the derivative with respect to time. So every time you take the derivative of a variable, you got to include d over dt. So again, I got 6 letters, so I need to assign those 6 letters. So this one, we got a little bit more work to do because they don't tell us what x, y, and z are. So I got those 6 variables. It tells us that the first train travels east at 45 miles per hour. So x is east, yeah?
Yes.
So that is 45 miles per hour. The rate of my other train is going south. The way I drew my picture and labeled it, south is y. So dy dt is 60. The question is, how fast is the distance between the train changing? So the question is, find that rate of change. So now I need x, y, and z. Well, x and y are given to you. What's x?
45 times 4.
We're going 45 miles per hour. So if I want to know the distance from there to there, distance equals rate times time. Our rate is 45. Our time is 4 hours. We left at 11. We got there at 3. So that means we traveled for 4 hours. Our y value, so we started at 11 and we started at noon. From the same point, we traveled south. So that one only was moving for 3 hours. So it's also 180. Good thing I read it. I would have said 4 hours again. But the other one left at noon. So he only was in operation for 3 hours at 60 miles per hour. So he went a total of 180 miles. When you're doing these, use exact numbers. Don't plug in some decimal yet. We want to be exact as we can be. So square root of 180 squared times 2. So whatever that is. 2.5.
You want the exact or like?
I want square root of the exact number. Put it right down, man. Easy. Yes, ma'am. Oh. That's right. Because I started it and then I couldn't. Okay, I'll do it again. Because I tried to do it one time and when I tried to on the computer, like, I don't know if I explain. When the little box for me thing that came up, I could only put 5 letters across. So like, I would write 6 letter words and the 6th letter would be on the next
She
line.
took off the hammer. This is the funny part. She took it off. Okay, after I was for class. After we took it off.
So 64800.
She had to keep it on for an extra hour.
Yeah, I'll do it for free. Yes, ma'am. You're welcome.
Square root of 6, yeah.
What?
That's 64800.
64800. I don't want to use a decimal. I want to use one decimal at the end. For the AP test, you're rounding everything up to the 3rd decimal place. So we need to make sure that 3rd decimal place is right. So don't round off now and then round off again in the answer. So I'm just going to round off once in the entire problem.
Why is dx over dt 45 and dy over dt 60?
Because the first train is moving at a rate of 45 miles per hour east. So I put the x there, so that means dx dt is the one that's going east.
So if it goes to speed, then that's always the derivative.
Speed is time, yes, it's a rate of change. So, just put the square root. So 2 times 180, because 180 is how far he's traveled. 45 miles per hour is the speed of x. And then 2 times 180 again, because that's how far the second train had went in 3 hours. And times its speed equals 2 times the distance between them. And then dz dt is what is changing. So. So 2 times 180 times 45 plus 2 times 180 times 60. Divided by 2 square root of 6480. Also, do not write this. Why is that wrong? Huh? Oh, besides the units. I'm going to put that in a second.
You said you only use 1 decimal?
It's 30.
Why is that wrong? Does it equal 74.246? It's almost there. So don't put an equal sign. Put your approximation sign. Because it is approximately 74.246. It's not exact. And we're doing miles per hour. So the rate in which the 2 trains are going away from each other is growing at a rate of 74.246 miles per hour. Questions anywhere?